Hey, grade sevens. This is area of a circle. This is a little thing. This is how they get the formula to calculate the area of the circle. I like this page. It's in your textbook. It's page 149. It says, suppose a circle was cut into 8 congruent sectors. The 8 sectors were then arranged to approximate a parallelogram. So they took a circle, they cut it up into 8 pieces, 8 sectors. There's 8 of those little almost triangles. There's an arch there. And then they took those and split them up and arranged them like so. The more congruent sectors we use, the closer the area of the parallelogram is to the area of the circle. Here is a circle that's cut into 24 sectors. The 24 sectors were then arranged to approximate a parallelogram. So instead of cutting it into 8, now it's been cut into 24 sectors, and they've taken those little pieces and rearranged them, all 24 of them, like so. And you'll notice when there's only a couple sectors here, eight sectors here, there's still these little bumps here, right? It's not quite a parallelogram, it's just really close. Whereas down here, some of you might not have even noticed that is actually little small arches, parts of the circumference, parts of this distance that goes around the circle. So now we've cut them into a bunch of sectors and it's closer to a parallelogram. Now, if we get so far that we're cutting these into so many sectors, eventually it would look almost exactly the same as a parallelogram, almost. The greater number of the sectors, the more the shape looks like a rectangle. The sum of the two longer sides of the rectangles is equal to the circumference. Okay, so the rectangle that we'll end up getting, the sum of the long sides, this side and this side, would be equal to circumference. Let me explain that. If we look here, these little arch lines, where did they come from? They came from these little portions that are around the circle. If we take all of those little portions and add it all up, it would be the circumference, which we use the variable c. It's this distance around the circle. So this right here would be 12 of these 24 pieces, and this right here would be the other 12. So each longer side of the base of the rectangle is 1/2 the circumference of the circle. So the circumference divided by 2, okay? That's what each of these sides would be. Do we remember this? Circumference is the same as 2 times r times pi, or 2 pi r is how it's normally written. That's from lesson 4.2. Circumference is the diameter times pi, or 2 times r times pi, because 2 times r is the same as diameter. So if you know the radius, you can actually figure out the circumference. And if you have the circumference, you could figure out the area of a circle. So the base of the rectangle, okay, the base of the rectangle equals 2 pi r divided by 2. Okay, so that base, this here, is 2 pi r. Why? Because c is 2 pi r. 2 pi r divided by 2. Now 2 and 2, if you take any number, you multiply it by 2 and then you divide it by 2, you're just going to get that any number. So this pi r is all it will be. The base will be pi r. Each of the two shorter sides is equal to the radius r. If you think about it, up here, these triangles are near triangles, they're not quite triangles, that we made here. What was one of these sides here? It was radius. It was the r, right? From the center to the edge is radius. So if you took one of these here to here, what is that? It's the same thing. It's r. So the sides of our rectangle will be r. So with that, we know that the radius would be our height, let's say, and c over 2 would be our base. And what do we know about a parallelogram? Its base times height is our area. So we can find out that the area of this would be our r times our c over 2, which our c over 2 we found out was 2 pi r over 2, which is the same thing as pi r. So all we need to do to find the area of this would be to take pi r and multiply it by r, which would be pi r r. Look through this one more time. The area of the rectangle is base times height. If the base is pi r, the height is r. So then the area of the triangle is pi r times r, which is the same thing as pi r r. And remember, with these exponents, an exponent just means multiply that thing right before it, that r, by itself twice. So pi times r is the same thing as pi r squared. This does not mean multiply by 2. They put this little example on the side. Remember, 7 times 7 is 7 squared, which means r times r is r squared. So when you're doing this formula, don't multiply by 2. You multiply r times itself and then multiply it by pi. So since the rectangle is made from all the sectors of the circle, the rectangle and the circle have the same area. So the area A of the circle with the radius r is area equals pi r squared. That is the area of a circle. If we know radius, we can come up with the area. If you know diameter, you could figure out the radius from that and then use it in this formula. And we can use this formula to find the area of any circle when we know its radius. We're going to do some examples in a different video.